Okay, we're going to talk about the distribution comparison question, which I'm guaranteed there will be one of these at least on the NCA exam. And we're comparing a normal distribution with a histogram of similar data, lifespan in hours of batteries. So when we do a comparison between a normal distribution and one that's not a normal distribution, then basically we're going to talk about centers, we're going to talk about spread, we're going to talk about shape, and then we should probably talk about something about their actual probabilities and the differences between them to give a fourth point. In this particular school exam, they wanted 4 points for excellence. So let's start with centers. Now, in this normal distribution curve, we can see that the mean is 15,000 hours. And if we look at the way this is distributed, it's going 17,000, 19,000. So we can assume from that the standard deviation is 2,000 hours. So we've got the mean and the standard deviation for this particular graph. Now, with normal distribution, we know that some things about normal distribution. We know the mean, the median, and the mode are all going to be in the center of the graph at 15,000. But that's not going to be the case for the histogram. And the reason that's the case for normal distribution is because it's symmetrical, completely symmetrical around the middle. But that's not going to be the case here. And this data is not symmetrical. Yeah, it's kind of bell-shaped, but it's not symmetrical. So what we have to do is we're going to have to actually find the mean and the median. The mode's not as important, and the standard deviation for the histogram data. So what we do is we use something called a midpoint method with our calculators. And what we do is we take the center of the columns in our histogram. Oops, right there. So that's 7,000. And in our calculator, what we do is we put in list 1, we put all those middle values for the columns in there. Okay, and then they've given us the frequencies, right? They've given us the frequencies here as 120, 240, and so on. So that becomes our frequency, and that goes in list 2 of our calculator. So what we do in our calculator is we go to the menu, we go to stat, and in list 1 we put our values, the midpoint values, and in list 2 we put our frequencies. Now the other thing that we have to do once we get that data in there is we're going to hit calculate, and we're going to have to set up our calculators and make sure that the first variable, which is our X list, is list 1, but then one var frequency, the frequency says list 2, the rest aren't important, but this is very important that it looks like this. And then you hit enter, and then you'll be asked, or you'll have a window that looks like this. You always select one variable because we're only looking at one variable, and it will give you your mean, which is your first number. That's your mean, X with a line over top of it. The X with this little mu symbol with N is your standard deviation. You go down and you get your median, which is the same as the normal distribution median, which is 15,000. So we do all of that to get our values. So now we can compare the centers. We can compare the centers of the normal distribution against the histogram. So it has to be a comparison, guys, right? It's got to be a statement that is a comparison. So while the normal distribution AI battery data will have the measures of central tendency at 15,000, the histogram has different averages as it's not symmetrical. Although the median is the same at 15,000, the mean is slightly lower at 14,224. You see, this is a comparison, slightly lower. And in fact, I'm going to say exactly how much lower. It's 776 hours less. Bingo. All right? So that's how you compare centers. You have to use numbers. You actually have to calculate and use your calculator to get those numbers, and then you compare specifically. Right? Very, very specifically. 776 hours less is the mean. Now, the next thing is we do the spread. Now the spread, you should do both the standard deviations, which is a measure of spread, and if you want the range. But most important is to do the standard deviation. So we know what the standard deviation for the normal curve is. It's 2,000. But for the calculator, it's showing us, when we did the calculations, as 3065.7 for the standard deviation. Now, standard deviation is a measure of spread. It is the average distance that each piece of data is away from the median. So this means that the battery life for the histogram is more varied. It's more spread out. That should be more varied. As the standard deviation is bigger, and in fact it's bigger, the standard deviation is bigger by 1,066 hours. So we have a bigger standard deviation from the histogram, which means that the data is more varied, is more spread out from the center of the graph. The range, if you want to do the range for the normal curve, is between 23,000 and 7,000, which is 16,000 hours, whereas the range for the histogram is 18,000 hours. Again, that shows that the spread of the data for the histogram is bigger, and it's bigger by 2,000 hours. So that's the range. The shape, pretty straightforward. The shape of the normal curve is bell-shaped and symmetrical, whereas the shape of the histogram is somewhat bell-shaped. Yeah, I mean, it's somewhat bell-shaped. Definitely, you know, it's got that center peak and so on, but it's definitely not symmetrical. And so you have to say that. The histogram, although it's somewhat bell-shaped, not symmetrical. There's more data to the left, you know, on the left-hand side here, more data than there is on the right-hand side. So I said that. It's not skewed so much, but it definitely has more data to the left than to the right. So that's 3 points. Now, for this particular school exam, we needed 4 points. So the 4th point would be a straight compare the probability. So what's the probability that x is greater than 16,000? 0.309. You just do it normally by putting in the standard deviation and the mean. And for a histogram, I just actually had to count. Bigger than, there's 560, 380, 40, and 20. I counted those up, divided by how many there was total, and I got 0.255. So for the normal curve, 31% lasts longer than 16,000 hours, while 25.5% lasts longer than 16,000 hours for an excellent 4 points.